Section 8.4 is on areas of triangles. When you have an area of a triangle, let's base that off of an area of a rectangle. If we have a rectangle here with a height and a base, we know the area of this rectangle is base times height. Now, a triangle with the same height and the same base is half as much. So the area of a triangle is 1/2 base times height. Okay, so here's where this comes in. The height of a triangle is perpendicular to the base. So no matter where the base is, the height has to be perpendicular to it. Notice this was a right triangle. This is just like the one I just showed you. This is just a normal triangle, but the height is going to be perpendicular to the base. It's not one of these other sides. And this height is way out here, but it is perpendicular to the extended base. So here's the formula, 1/2 base times height, just like I mentioned. It doesn't matter if the height's 8 on the outside and the base is 13, it's going to have the same area as if those two are like this, or like this, or like this. It doesn't matter. The same area. Find the area of the right triangle. Well, that's very simple because it's just area is 1/2 base times height. So when you're doing your problems, I always want you to write the formula down. You'll learn the formulas, you'll be able to work the formulas better. Times 10 times 6. So that's 1/2 of 30. I'm sorry, I already took 1/2. 1/2 of 60, which is 30. Don't forget to label your answers centimeters squared. Okay, here's another triangle. It's not a right triangle this time, but it's the same formula. 1/2 base times height, 1/2 times 8 times 5 is 1/2 of 40, which is 20 feet squared. Find the height of the triangle given that the area is 39. We're still going to use the same formula. The area is 1/2 the base times the height. Again, I want you to write your formula down every time. It says the area is 39, so this time we're going to put 39 here. We've got 1/2, we've got a base of 13 and a height. What I would do on this one is I would get rid of the 1/2 first by multiplying by 2. That eliminates that. This gives me 78 on this side and 13h on this side. Now I will divide by 13. Okay, so that will be 6. H is equal to 6. And again, because you're talking about a length, not an area, it's just inches. Just inches. Okay, try these, and then I will come back and give you the answers and see how you do. Okay, welcome back. Number 1. We have 1/2 times 8 times 9 is 36 inches squared. Number 2 is 1/2 times 12 times 7. What you could do is take 1/2 of 12 first and get 6 times 7, which is 42 yards squared. Number 3 is 1/2 of 15 times 16, which is, if I wanted to, I could take 1/2 of 16 first to get 8 times 15, which is 120 centimeters squared. Okay. Let's go ahead and erase this and do number 4. Number 4, the area is 1/2 the base times the height. The area is 84, 1/2 of 14 times the base. Now I could multiply by 2, but I could actually easily multiply this first and get 7. And then divide by 7 and I get 12. 12 and it's inches. Again, not inches squared because it's a length. Okay, find the ratio of the areas of a similar triangles. Remember we talked about similar triangles last chapter? It says the scale factor of triangle ABC to triangle DEF. The scale factor for these is this triangle to this triangle would be 4 to 6 or 2/3. So that's the scale factor of the sides. The areas, the ratio of the areas, this is 1/2 of 8 or 4. So the area of ABC is 4. The area of triangle DEF is 9. So the ratio is 4 to 9. Okay, so let me back up and slow down a little bit. It says find the ratio of the areas of the similar triangles. So if we find the area of this, the area is 1/2, 2 times 4, so that's 1/2 of 8 is 4. That's how I got 4 here. The area of this triangle is 1/2 of 3 times 6, which is 3 times 6 is 18, 1/2 is 9. The ratio is 4 to 9. The scale factor is 2 to 3. Okay, so here's the lesson. Here is what they're trying to show you. That when you have a scale factor of A to B, the ratio of the areas is A squared to B squared. Now, look at that. This is 2/3. If I square that, it's the A ratio of the areas. So if the scale factor of one triangle to another is A to B, the ratio of the areas is A squared to B squared. Areas of similar polygons. So they just basically go over this. It says if two polygons are similar and have a scale factor of A to B, then the ratio of their areas is A squared to B squared. And that's what that's about in section 8.4.